Hello, my wonderful 7th graders. In section 4.2, we are going to be solving equations with multiplication and division. So in section 4.1, we were solving with adding and subtracting using inverse operations, which if you remember are operations that undo something that has been done to the variable or undo another operation. So in 4.1, if we had a variable that had something added to it, the inverse operation we used was subtract. If we had a subtraction situation, the inverse of subtraction is adding. So now in this section, we're going to be still using inverse operations. We'll just be doing multiplication and division. So if we have a multiplication of our variable, the way we undo multiplication is with division. And if we have division, the way we undo division, or the inverse of division, is multiplication. All right, so take a minute to pause the video if you need to make sure you have this chart written down, and then we'll just jump straight into some examples. So in this first example, solve x divided by 3 equals -6. So we're solving for x. So I'm just going to start by rewriting this problem out. And now when we're solving equations, remember, we have to think of our equations like a balance beam, right? With the equal sign being the center of our balance beam, okay? So x over 3 is the same as -6. Those are balanced, even though they look different. We're trying to figure out what x is to make x over 3 the same as -6. So if we do something to one side of the equation, we have to do the same thing to the other side of the equation. That's a huge, huge key idea. It's even such a big key idea, you might just even put a little star in your notes and say, we have to do the same thing to each side of our equation. And that's just to help keep it balanced, because if you don't do the same thing to each side, it won't be balanced, and when you solve for x, it won't satisfy your equation, or it won't make it true. And so what we do when we're solving these is we look at the side of the equation that has the variable on it, and we're trying to get the variable on its own or isolated, so we want to undo whatever is being done to the variable. So I look at this, and this left-hand side here is the side of the equation with my variable on it, and we have x divided by 3. So x is being divided by 3. So the opposite of division is multiplication. So to undo x divided by 3, I have to multiply by 3. So I'm going to multiply the right-hand side of this equation by 3. And anything I do to that was the left-hand side. Anything I do to one side, I have to do to the other side. So I also have to multiply the right-hand side by 3. And so what happens is 3 times x over 3, I can really think about this as 3x over 3, and then 3 over 3 is 1. So that goes to 1. So we've really turned, by multiplying x over 3 by 3, we've turned it into 1x. All right, and then on the other side of the equation, we have -6 times 3. 6 times 3 is 18, and a negative times a positive is a negative. So I really want you to show your work, show each inverse operation you're doing. That is what I care about, because even though you could maybe look at this problem and know just from looking at it that x has to be -18, as we start to get more and more complicated problems, you won't be able to just look at it and know. So it's super, 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 super important to practice using these inverse operations to solve, so that when we get to harder problems, you can solve those ones too. So actually, as we're going through, like on your quiz, I won't even give you credit if you don't show your inverse operations. So it's super important that you're showing that. So I changed this into, so now I'm just going to write my final answer. So x equals negative 18. And I'll circle it. And I can do a quick check on this to make sure I got the correct answer. So if I substitute negative 18 in for x, so we have x over 3. So if I substitute in negative 18 in for x right there, and then rewrite the rest of my equation, I get negative 18 over 3 equals negative 6. Well, negative 18 divided by 3 is negative 6. So we get negative 6 equals negative 6. So we got the right answer. If you got the wrong answer for x and you substituted back in, you'd get something funny like negative 5 equals negative 6. And you said, oh, nope, that doesn't make any sense. So I'm going to go back and see what I did wrong. Okay. All right. Now let's go on to the next example. So the next one is solve 18 equals negative 4y. And so what's really being, so the first thing we want to do is look at the side of the equation with the variable, because that's what we're going to be undoing. So that's the right-hand side. And so y, the variable, is being multiplied by negative 4. Oh, whoops. Oh, what happened there? 1 second. There we go. Okay. So negative 4 is being multiplied by y. We don't really write the multiplication symbol, but that's implied. That's what's happening there. So in order to undo y times negative 4, we have to divide y by negative 4. So we divide y by negative 4. And it's important to include the negative. We have to divide by the same exact thing that y is being multiplied by. So if it's being multiplied by negative 4, we have to divide by negative 4. And if we do something to one side, you guessed it, we have to do the same thing to the other side. All right, and I want you to show these inverse operations. So here, where our inverse operation of multiply by 4 is divide by 4. So I want you to show that step for credit. Okay. So, negative 4 divided by negative 4, that's 1. So we've really turned this into 1 times y equals 18 divided by negative 4. I'm going to change that into a mixed number real quick. So groups of 4, there are 4 groups of 4 that fit into 18, because 4 times 4 is 16, and then there's 2 left over, and I pull my negative out. All right. Now, 4 and 2/4 can be simplified a little bit more. So if I divide the numerator by 2 and the denominator by 2, that gives me negative 4 and 1/2 equals 1 times y, which we don't have to write the 1 times. We can just write equals y. So that is our answer for that. And then if we substituted negative 4.5 back in to our original equation, we would get 18. And a good, even quick check is negative 4 times y. We know y has to be negative because it has to equal positive 18. So a negative times a negative has to be a positive. Alrighty, let's do a few try-it problems. Okay, so why don't you copy these try-it problems down, give them your best try, pause the video, give them a try, and then when you're ready, you can restart the video and see how you did. Okay, so for the first try-it problem, we have x over 5 equals negative 2. So the first thing I want to do is I want to look at the side of the equation with a variable and see what's happening to it. So x is being divided by 5. The inverse operation of dividing by 5 is multiplying by 5. So I have to multiply my right-hand side of my equation by 5. Or my left-hand side. Man, I keep mixing up my left and rights. So if I multiply my left-hand side of my equation by 5, I have to do the same thing to my right-hand side. Okay, so this 5x divided by 5, that 5 over 5 becomes a 1. So if you wanted to show your work, you could even do that in this step, this first step. You could go 5 divided by 5 equals 1, and then write for your next line. Oh, whoops, hold on. Write for your next line 1, that turns into a 1 times x equals negative 2 times 5, which is negative 10. So x equals negative 10. And then if we do a check, we substitute negative 10 into our original equation. So our original equation was x over 5 equals negative 2. So I substitute in negative 10. And then negative 10 divided by 5 is negative 2. So I get negative 2 equals negative 2. So that checks out. Awesome. All right, this next one's kind of tricky at first. So negative a equals negative 24. So we're trying to get a just on its own, not negative a. So what's really happening here is negative a. We don't write the 1, but it's really like negative 1 times a equals negative 24. So in order to get rid of negative 1 times a, we have to do the inverse operation of multiplying by negative 1, which is dividing by negative 1. And if I divide one side by negative 1, I have to divide the other side by negative 1. All right, so negative 1 divided by negative 1 turns into a positive 1 times a equals negative 24 divided by negative 1 is a positive 24. All right, so a equals 24. So you can, and then if we substitute that back into the original equation, negative a is 24 equals negative 24. So sure enough, that checks out. Negative 24 equals negative 24. Since we're learning inverse operations, I like to show this as an inverse operation. There is another way you could think about it though. You could think about this problem and be like, oh, I have a negative a. I want to change it into a positive a so I can multiply one side of the equation by negative 1, which I would have to multiply the other side of the equation by negative 1, and I would still get the same answer, a equals 24. Okay, last try it problem is 3 equals negative 1.5n. So I have to undo what's being done to the variable n, so I start on that side of the equation, the right-hand side. So this is n is being multiplied by negative 1.5. So the inverse of multiplying by negative 1.5 is dividing by negative 1.5. And if I do that to one side, I have to do it to the other side. So I'm going to divide the left-hand side by negative 1.5. Well, negative 1.5 divided by negative 1.5 equals 1. So this turns into 1 times n is 3 divided by negative 1.5. So that's going to be a negative 2. So n equals negative 2. And if we substitute that back into our original equation as a check, our original equation was 3 equals negative 1.5 times n, and I'm going to substitute that negative 2 in where the n was. So 3 equals negative 1.5 times negative 2 is indeed a positive 3, and negative times a negative is a positive. So that works out. All right, if you have any questions at all, please come to my office hours on Google Meet or shoot me an email. I'd be so happy to meet up with you and go through some more problems if you have any questions. The most important part about this is to show each inverse operation, because even though you can maybe do it in your head right now without showing the inverse operations, believe me, these problems are going to get harder. So if you don't know how to do the inverse operations, you won't be able to solve those harder problems. So again, even on the quiz, I won't give you credit for just the answer. You need to show the inverse operation to get credit. All right, you are all wonderful. Thank you so much for watching.